Data pre-processing is a very important step in computer vision pipeline. So first of all, before we do our inference, we basically have these three different steps, which is part of the inference. We have data pre-processing, then we have the inference itself, where we pass the image through a model, and then we get the post-processing, where we, for example, do non-maximal suppression and so on before we have the results out with our classes, confidence scores, bounding boxes, and all that we get out from the model. But in this video here, we're going to talk about data pre-processing, the different steps that you can do, how we're doing it at Ultralytics, how it affects your data, your training, and all of that. So first of all here, let's just jump straight into the documentation. We have tons of different guides in here. So if you go inside the guides tab, we can scroll down all the way here. We have pre-processing annotated data, cover all different types of computer vision, tips and tricks, guides inside here. We have videos for most of them and also documentation that you can go through. But if you go inside the data pre-processing techniques for annotated computer vision data, first of all, we have introduction, then we have why it's so important to do data pre-processing, which is basically just if we have imbalance in our classes, we can do something for that to take that into account. Could be inconsistency in our training data. We need to have consistent data so a model can learn from that, but also just be able to pass it into the model and run our training loop. Could also be noise, which is irrelevant, or random variations in the data that we want to minimize as well. That could, for example, be normalization, standardization, and so on that we can do, but we just need to have consistent data that we pass into it. Here with Ultralytics, we're basically converting all the images to RGB format. Then we do normalization, so the values are between 0 and 1. Also some standardization, where it's basically scaled with a known mean and also like a standard deviation. So it's basically just a distribution of our data, but we want to have the values between 0 and 1 because the models, they're working with that. It's way more stable to train the AI models. They'll be able to generalize better and so on as well. So most often when you work with computer vision, machine learning, deep learning, AI, pretty much any type of data, you always want to go in and normalize it. Often value between 0 and 1 because we have the activation functions and all that, which benefits a lot from having these values and just makes it more numerical stable when you train the models. So a very important step in the data pre-processing pipeline as well is resizing images. So that could, for example, be that you have all different types of image dimensions, image resolutions in your data set, but when we actually train a model, it needs to be the exact same resolution for all the data that we're passing into it. So resizing is a very common data pre-processing technique. All that is taken care of automatically with Ultralytics. We just need to specify the image size and it will basically just resize all the images before passing it into the model. Either running inference, model training, or whatever. You can do it in different ways. So bilinear interpolation, nearest neighbor, and so on. It's basically just how it interpolates when it downscales the images or even upscales as well if you have lower resolution images but want to train on a larger model. That is very helpful if you have a lot of variation in your image resolution in your data set. Normalizing pixel values, we already went over that. So we have min max scaling, so values between 0 and 1. C-score normalization, so that means, for example, in min-max scaling, if you have integer values between 0 and 255, we have 3 channels in an RGB image, then we basically have a value for each of them between 0 and 255 if you have an 8-bit image, but then we actually just scale it down to 0 and also 1. If you want it back into a normal format again, you can just multiply it with 255, because if you multiply 0 with 255, you get 0. If you multiply 1 with 255, you get 255, so we're covering the whole range. C-score normalization, so it scales the pixel values based on the mean and the standard deviation of it, and here with Ultralytics, as you can read here, it's basically just using this normalization with a predefined mean and standard deviation. Then we go in, split the dataset, data splitting for our train, test, and validation split. It is very important to have, so that's also a pre-processing technique, but even a bit further step ahead. So often you split your data, and then you go in and apply data augmentation, normalization, and all that need to be consistent across all of them, but we only want to apply data augmentation most often on our training images. So here for splitting it, just maintaining data distribution, avoid data leakage as well, and also balancing classes. So if you for example, like have only a few classes and they're not really represented in your training set and more in your test and train set, it might not be able to learn those classes. So make sure that you have a balanced data set, or at least enough samples of each class that you want to detect in your training set, because this is what the model is going to learn from. And then we have our validation and test set, which we tune our height parameters based on for evaluations, and then our test set to see how good our model generalizes. Then a very important step here, either if you don't have enough data, you want to have your models generalize even better, then we have data augmentation, which is basically just creating new images based on the images that we already have. We could rotate it, we could shear it, we can apply different lighting augmentations, so that could be basically just the intensity of the pixels. We could have saturation, lighting, all that could be augmented with our data. So it's very good for just creating more robust data, make the models generalize better without we don't really need to spend that much time. We just have these augmentation techniques, we apply it on top of our data, and then we have our augmented data set. So this is better use of data. We cover a lot more examples, SKs and so on. To say that you want to detect a car and you won't have a car pointing in this direction, you can actually just do a flip. So you also have data where it's pointing in the other direction. So it just helps with generalizing better. So this is one of the most important steps for your data set, at least for the pre-processing steps, if you want more data. Of course, pre-processing steps with resizing the image, normalizing values and all that, we need that to be able to even have our models learn anything at all. But if you want to make your models even better, generalize better, data augmentation is very good for that. Random crops, flipping, rotation, distortion, all these different steps here can apply on top of it. You can also go in and do data analysis. So it's really important to see if you have any class imbalance. Could be that you only have a few examples of one specific class. You might not be able to go in and see it. So you can go in, apply different techniques for seeing that. You can have histograms and box plots, scatter plots, heat maps. You can even see, okay, in this region of the image, I have most of my detection. It's not really covering the whole image frame. Then you can use that to go in and optimize your data set. So this is more act like going in, optimizing, post-processing your act like annotated data, not the pre-processing before you pass it into the model, but basically just to get a very good understanding of how your data is. The most important is the data that you feed into the models. Trash in is also trash out pretty much. If you're not getting good results with the models, it is most likely 99% certain that it's in your data set. So spend time optimizing your data set, try out these different techniques. Also, if you set up something on your own. So you can go ahead and explore the image embeddings and so on the Ultralytics Hub, as we can see here. Then we can see a distribution of our data, different examples. We can even query our examples that we want to take a look at. So it's a good way to get insights into your data set. Focus on getting a good data set, apply the correct pre-processing techniques that we went over here. It's also important to know what are these pre-processing steps actually doing, as I went over. Use data augmentation to get a better generalizable model, but also just expand your data set without really doing anything. You can do all of it with Ultralytics. Definitely go in, check it out, test it out. It's only a few lines of code and you have it up and running. It's very important that you do this in your computer vision applications for the best models possible. Trash in is also trash out. Hope you learned something in this video here. Definitely go through it and also test it out in your next project. Then I'll just see you guys in one of the upcoming videos. Until then, happy learning.